Okay, hello everyone. My name is Shamir. I know it's really close to beer o'clock, so I'll try and make this short and sweet, and we'll get through it. Although there is a keynote, ending keynote, Steve I think is talking, so that'll be super fun. Just so I can kind of tailor the presentation as I'm kind of talking, I'm curious who uses the public cloud right now for their data lakes. One, two, a couple people in the crowd. No, not you. Okay. Are you primarily AWS? Put up your hand if you use AWS. S3 with no. How about Azure? IBM Cloud? Nobody? Okay. All right. Okay. So my name is Shamir. I'm a CPO at Deturk. We are a cloud security company that's focused on data lake security, basically in the public cloud, mostly focused on Azure at the moment. And this talk is about data lake security, kind of talking about some issues that we have today as we deploy data lakes in the public cloud, and then a little bit about what's kind of coming down the pipe in terms of regulation, other things that you might want to consider when you are creating your data lakes in the public cloud. All right. So on the agenda, cloud data lake security is a pretty big topic. I could probably spend maybe all of B-sides talking about it. So I'm going to just talk about kind of three main areas around cloud data lake security. First is around creating appropriate identity and network boundaries for your organization. The second one is talking about different RBAC strategies and different things that you can do around service and user type authentication. And the last one's going to be on data visibility. And when we talk about the kind of the beyond section, I'll talk about a couple of regulations that are coming down the pipe. The first one is here in Canada, Bill C-27, which is the new Privacy Act, or the update to the Privacy Act. And then the second one is a project out of the EU called Gaia-X. And it's kind of an interesting take on data regulation and kind of the new data economy that they're trying to build out there, and the regulation that the government is introducing. So if you want to partake in the data economy, you're going to have to conform with. All right. So just level set kind of in the room in case people don't use data lakes. The first one is, what is a data lake? So back in the olden years of maybe 5 years ago, we used to use databases for all of our quote unquote data lakes. And if you've ever been involved in a project that claimed that they were doing business intelligence or something like that, that's effectively what you were doing. You were taking one large database that combines your compute, your storage, your access controls, your logging, and so on to that database. And what we realized very quickly was that model doesn't scale, or more importantly, if you do want to scale, you end up paying SAP a lot of money. So we moved from a big old database to doing what we call a data lake right now. And so what a data lake does is it abstracts a couple of those concepts around compute, around your identity provider, and around centralized logging, but still enforces some of the basics around security access controls. So you basically have what we would call blob storage, and you would put your blobs in there, and your blobs would represent sets of your data. And you can structure them as tables if you want, or you can leave them unstructured as well. So PDFs and video files and so on and so forth can go in there. And if you ever wanted to use them or analyze them, you would bring your own compute. All these different types of products that sit on top of these data lakes that bring your compute on demand for when you want to make a query. And the other thing that we abstracted out was the identity provider and the centralized logging. So most of the public cloud providers have a very opinionated way of how they want you to do identity and logging, i.e. they want you to use their services and no other. But the idea is that identity provider and the centralized logging would be separated from the storage account itself and allow you to maybe get a little bit more creative with your target architecture. So where are we going tomorrow? Tomorrow, I think what we're looking at is something similar to what I've got on the screen here, where the idea is that data lakes, and I use the word plurally, in our organizations represent these kind of spaces of data that our business wants to share. And that sharing may occur business to business with my business partners, may occur business to government or B2G, may occur B2C, business to consumer, or might just be intra-business in my own business itself. And what I'm doing then is instead of relying on the data space itself to provide identity, trust, the catalog, some type of data exchange, and some type of compliance framework, I'm actually taking those concepts out and putting them as kind of this abstract layer that I interact with that wraps my data spaces together. And then my services would then connect to these data spaces through this kind of federation service that provides all of these features and functionality. So it gives me this semblance of centralized control around how data is used in those data spaces without, but not having to centralize my data as well and bring all of the problems that come with that. So last slide on kind of what is a data lake, just if you do use Azure or AWS in terms of your data platform. In Azure, the main service that's storing all of your blobs is called Azure Data Lake Services Gen 2, or ADLS Gen 2 as it's called. And that one's going to provide kind of your storage access controls. Typically for logging, you're going to use something like Log Analytics. For governance, you're going to use something like Azure Purview. And then for identity, you're of course going to use Azure Active Directory. And then you might have one or more services that connect into your ADLS Gen 2. There's just a couple of the ones that you could use. Azure Data Factory, for example, for kind of orchestrating and doing your data movement. Azure Databricks, if you want to do some heavy compute or start kind of having exploratory type data work done. And then Azure Synapse is kind of a competitor to Azure Databricks, kind of not, depending on who you talk to, but same sort of deal. So you're bringing those are the compute engines that you can bring to kind of do the queries and stuff like that on your data. On the AWS side, you obviously have Amazon on using lake formation here. You could use S3 without quote unquote lake formation, which basically just doesn't do AWS glue for you. So you don't get kind of a table structure and that governance structure on your data. You just be deploying blobs directly. In the AWS ecosphere, logging is obviously done through AWS CloudWatch. You can do governance through AWS Glue, and then you obviously have identity, and that's done through AWS IAM. And of course, from a services perspective, you've got different services in AWS. They work a little bit differently than the ones in Azure. Athena, Redshift, and EMR all kind of bring your own compute type clients that you can add onto your data lake. So now that we know what a data lake is, Mr. Burgundy here is going to let us know that networking is kind of a big deal, and it surely is. So let's talk a little bit about the network boundary that you can create around your public cloud data lake. So hyper theoretical here, or getting really high level and into the theory. Cloud providers basically have two network boundaries that they enforce whenever you access a service. This doesn't have to be ADLS Gen 2 or Amazon S3. Any service will work like this. Basically, you have your cloud provider network boundary, and then you have your cloud provider service boundary. And depending on what configuration is available to you from those public cloud providers, that depends on that small blue box there at the top, the service endpoint configuration. That'll influence what you're able to configure and what you're able to not configure. So the teal is in the provider responsibility, and the blue is in the customer responsibility. It's important to remember this, that when we talk about systems in the public cloud, we talk about internet boundaries, non-internet boundaries. A lot of that is not in your control. Those are not things that you should be worrying about because they're not in your area of the shared responsibility model for security of one of these services. What is important is the service endpoint config and how you kind of configure that. So of course, right now, if you're a tried and true security professional or a vendor, you're going to go blah, blah, blah. What about zero trust? And then I'm going to just move on to the next slide. All right. Network boundary. So network boundary, it's important that there's basically think about your service as accessible through what they call endpoints within the public cloud. And there's public endpoints and private endpoints. And this is really just telling the service where to listen. If you think about it, Azure Storage or Amazon S3 are global services. They're always listening out on the internet. There's nothing you can do about that. But what you can do is configure where the service should be listening to or should be accepting traffic from. And that's what the difference between public and private endpoints. In the public endpoint realm, you have just basic IP restrictions. So think like your typical layer 3 firewall. And then you have enhanced restrictions, your layer 3 firewall with VLANs, basically. And then you have your private endpoints, which allow you to address your services using private addresses. And so in Azure, you typically configure the Azure Storage Firewall. With the enhanced restrictions, it's the Azure Service Firewall with service endpoints, where if traffic is originating from a virtual network inside of Azure, they will put a special tag on that traffic. And then they will investigate is coming from that virtual network. So just think about it like VLANing, but in the public cloud. And on the AWS side, you basically do the same thing through bucket policies, and then bucket policies with VPC endpoint policy, condition tags on it. So the key takeaways from network boundary are that endpoints are really just configuration about where to listen. You can't really think about it in terms of internet and public. It's a very blurry line in the public cloud. And so thinking about it in that kind of traditional sense is going to lead you to make fairly poor decisions about how you want to structure your storage and how you want it to be accessed. And the second part is that you have to consider the shared responsibility model between the providers and the consumers and understand what is in your control and what you should be worried about, and then the parts that you shouldn't be worried about. So for example, DDoSing your storage account is not your problem. That's in the shared responsibility model of the provider. And the last one is that private endpoints may increase security because they quote unquote are only privately addressable. Again, in a very loose sense of that word, but they definitely increase costs. It's definitely a premium feature that both cloud providers charge you for if that is what your security team is mandating. So moving on from network boundary, let's talk a little bit about network detection. So basically, now that we've talked about how you can protect your storage accounts, this part is about how you can understand what is happening in your storage account. And network detection can be done through the logging, of course. You can log all server requests to both the Azure and the AWS services. But both cloud, you can see that. Some artificial intelligence, I guess, to look at your storage logs, because of course your storage logs are occurring at scale, and try and understand whether some of that traffic is bad or not. In Azure, they have the Microsoft Defender for storage, and in AWS, they have AWS Guard Duty. I'd love to rename these cloud services because they don't make much sense. I've never seen Defender defend against anything. It more snitches. So it's Microsoft Snitch for storage is probably a better term. It'll tell you if something's wrong, but it definitely won't block anything. And AWS Guard Duty is more like the mall cop. I mean, if it's really obvious that something's wrong, it'll tell you about it. But if somebody's being pretty thoughtful about what they're trying to do, it's not going to catch you much. So typically, these services apply obviously to the blob storage that you have, and they have different alerts and everything that you can configure. The most interesting one, I think, is on the AWS side, where they will warn you if your storage account gets pen tested. I think that's basically signature detection using the user agent. So if you have a good pen tester, that should almost never go off. Okay, so we've talked about network boundary. We talked a little bit about what you can do at the detection level. Let's talk about identity. This guy's super smart here. There's two reasons he doesn't trust people. One, he doesn't know them, and two, he knows them. I'm sure that resonates quite often. Pitch their own services as kind of your identity provider, your authorization and authentication mechanism. In Azure, that's Azure Active Directory, and in AWS, that is AWS IAM. And of course, there's different ways that you can kind of configure your identity boundary within the different cloud providers. On the Azure side, you can use Azure RBAC, which is effectively just providing just placing the RBAC controls at the Azure resource level, if that kind of makes sense. There's part is just a Linux file system, and you being able to configure the POSIX controls. And then there's storage ABAC, which effectively allows you to use tags. And don't worry, we're gonna get into some of the differences here when we talk about RBAC strategies. On the AWS side, you basically have two main ways of doing things. Both of them revolve around writing really fun JSON policy documents and applying them in different areas to get unique results. The key thing to think about your identity boundary is that you don't have to rely on just like use identity from Azure conditional access or Microsoft conditional access, whatever it's called these days. But effectively, it's looking at more of the attributes around the authentication and authorization requests that are being made, user and location, application, real-time risk, which I think think it's basically whether you have an antivirus or not, and different or maybe block access. So you can do this in both clouds. It's just this is an Azure diagram, but think about when you're setting up your identity boundaries, also setting up things like conditional access so that you can strengthen that control. So the identity boundary, what it looks like in Azure is Azure AD conditional access for user and workloads. And you can basically, like I said, do location, risk, and MFA type policies. And then the last one there is that you can create what's called managed identities within the Azure platform, which is effectively, think of it, if you've ever done Active Directory in your past, think of it as a computer account. You're basically giving a computer account to a service and then granting that computer account access to a set of resources, and that is just managed by the platform for you. You don't have to manage keys or do anything like that. On the AWS side, you can use conditions on your policy tags. There's different conditions that you can add, like whether multi-factor was present at the authorization time, what the source IP was, the user agent, and so on and so forth. And AWS also has a concept of managed identities. It's called instant profiles. So I think the core part here, when you're thinking about your network and your identity boundary, is thinking about trying to combine them to achieve your kind of security goals in the public cloud, right? Thank you, Keanu. All right. So basically, it looks something like this. You can use your network boundary to paint with what I'll term the big brush, and so anything that may, let's say the non-prod network. But within that non-prod network, you can then make use of identity controls to protect the different data spaces for the identity, the actual running of the identity, the actual enforcement of that is in the cloud provider shared responsibility model. That's not your risk. We trust it less, depending on your threat profile. That identity boundary will do what it's supposed to do. And so you can kind of layer these controls together, where you use the network kind of in this broad brush to keep everything semi-private, and then you use identity within that to get to the granularity level that you want to get to. Typically, RBAC strategies in most organizations, especially around the public data cloud, data lake in public cloud. I think I said that right. Everybody gets admin. That's what they do. They do that because it's hard to manage RBAC at scale. It's hard to manage hundreds of thousands of folders and petabytes of data. So what they do is they just give everybody admin, or they turn over admin to the data analytics team, and they kind of just hope for the best. So RBAC strategies, this is a really high-level slide here. Basically, it's how ACLs work. So as a user, I want to access data elements. I basically have to my request gets authorized through an ACL policy that runs somewhere, usually on the storage account itself, before I get access to the data element. Now, there's a couple of different things that you need to consider when you're talking about policy assignment. In a lot of cases, when you're assigning it to the entire storage account. So policies. Now, you could probably think through that and go, well, that's not going to be good if I combine my accounting data with my HR data, with my metrics data, with my OT data, right? You're going to want some sort of segregation or some type of policy assignment that takes into account that you have different types of data being stored in. As I'm on this next, it is POSIX controls. POSIX does not have inheritance. If you've ever had to chmod a large directory with lots of files, you sit there and wait until it completes, because it has to touch the AC is set up. You need to run, how do you need to run it, who needs those permissions, what permission does the runner need to have? And what does that mean for your data security? In a lot of cases, for example, to configure ACLs, you need to be owner of the data, which means that all of my admins can see all of my data, regardless of the data sensitivity and classification. And the last one is ACL sizes and limits.